You know, after this talk is lunch, right? So between now and lunch is a security talk, and you all opted in for that. How ironic. Let's make one decision. If you take your phone out now, go to the DevOps app and put a 5-star rating in and you leave early, I will not complain. But before that, let's get into this. Space, the final frontier. That was the tagline of one of my favorite shows during my childhood. Star Trek, The Next Generation. Okay, maybe it is an obvious one. Who's seen this series? Who is more a Star Wars kind of person instead of a Star Trek? Who is more a Star Trek kind of person? Who, I have no clue what this is a kind of person? Cool. And I'm more of the person, I don't care. Who is with me? I mean, if it shoots in space, it's awesome. That is my point. So we're not getting into a Star Trek versus Star Wars thing. But one thing I like about Star Trek is that everything in there can be real or already is real. I mean, some of the things that they created in the older series of Star Trek were not actually there when they created it. However, if we look at the computers, if I would give this to any kid, it would like, what is this, dude? It's a box with lights. My phone has more computation power than... I cannot play Minecraft on that. You get me? If you look at the series, these older series, then you have that point where they have these automatically opening and closing doors. There weren't sensors at that time. So there were people behind the scenes opening and closing the doors. Just look at it and see that they are not synchronous. Watch it. It's fun. However, so reality actually blend in, and the reality is now way further than the older series of Star Trek. One thing I would love that becomes reality someday is this one. Getting myself from here to another place, like decomposing myself, a human body, into a stream of data, sending it over the air to another place, and composing that same body again in another place, which, man, you know, because air travel is a pain. But this is exactly what we're going to talk about, because we're already doing this, only with objects. My name is Brian. I am a developer advocate, which means I code a little and email a lot. No, I'm kidding. Java champion, do something in the community, virtual jug, analjug, and a bunch of other things. But we're going to talk about serialization today. Not about me, but this is the mandatory, hey, look at me, I'm pretty. Anyway, serialization is also called the gift that keeps on giving. That sounds like Christmas, but it's not. It's in the most horrible way you can imagine. Who knows what serialization is and used serialization somewhere in their past life of a developer? Good. For those who are like, I have no clue what this is, I will give you the TLDR. Serialization is I have an object, I transfer it into a byte stream, and I can send it over the network or store it to a file. Right? Deserialization, and there is where all the magic happens, is the other way around. So we have that thing from the network or from the file, that byte stream, and we transform it back into an object. Well, that was it. Thanks for joining my TED Talk. Now, I mean, serialization is implemented in Java, and I'm talking about the custom serialization, in such a way that it's easy to use for developers. That was the core decision of that. So, say I have an object over here, which is a value object, and has two parameters, or two fields, value and side effect. The first thing I can do, the only thing I need to do to make this serializable is this. Again, done. However, we see something here. This is the constructor. So normally if you construct the thing and you put the value in, the value gets set. And the side effect is something that is set by the constructor. And you can imagine that sometimes in a constructor you put logic in to validate an object, to make sure that the object is in such a state that it is actually true and is representing the true value you want. Well, the thing is, if we serialize this again our value object, these are the lines you need to use if you want to serialize it and put it into a file. All fine, right? File output stream, object output stream. I write the object output stream into the file, and I close it. Nothing wrong with that. Pretty easy, done, get to our next task on our sprint board, or Jira board, or Kanban board, whatever you use, it's fine. Say we have this as a file, and I look at that file, I can actually read it. Hex editor, looking around it, and I can read it. And I see that my value is high, and the side effect is the timestamp, which was supposed to be the thing. Cool. But this means I can read it. It's not encrypted, encoded, just send over the line. So if I do, say, I can reach that file, or I can do a man-in-the-middle attack, like I just go into your stream, I can change this simply into this. What does this mean? Well, it's an easy protocol, so I can change values. But you know, the thing is, because we deserialize it in a minute, I can change values, which means I also can change if the thing is actually the thing you expected. You simply don't know. There is no such thing as a checksum or whatever, so that means potentially we can have values in our system that are not in the state as we expected it to be, or maybe invalid. The reason for that is deserialization. So again, our object. And now, this is the way how we deserialize things. File object, file input stream, object input stream, and then the third line. You see what I'm doing here? In.read object. So that object is somewhere in memory, and then I cast it into a value object. There are so many things wrong with this. First of all, we don't go through the constructor. So that means all fields will be set into that object reflectively using Java reflection. That means that the state that thing was in will be just transposed into that object. Sounds fine, but if I can change the objects and I have something in my constructor that validates that object, we are not sure anymore if that object is actually in the state we want it to be and can be in an invalid state, which screws up my whole system. Okay. But then that in.read object, it reads an object. Fine. At that point, I have no clue what that object is. What is the kind of thing, what kind of exception I get if it is not a value object? Who knows that? A Classcast exception. Think about it. It is already in memory, then I try to cast it, and then it goes wrong. Hold that thought. It is already in memory. Because now we're going to the second part, like, yeah, okay, you can change values. Ooh, scary. But that doesn't happen, right? Who's heard of gadgets? And I don't know, I'm not meaning this guy, but actually gadgets. Who knows what a gadget is? And I don't mean your smartphone, like a gadget in an object. 3, 4 people. All right. Well, a gadget is an object that if I put it into memory, or I actually make an instance of it, it has a side effect. And hopefully, for me, as a malicious person, a side effect that can execute code. So, say this is my gadget, and you see I already implement serializable. The field I have here is a runnable. And what I do is, you know that deserializing thing again, that in.read object? I can override the read object, even though it's a private final void. You might, Yes, that is possible. What I do now is, if this thing comes into my stream and comes into my program, even though I try to cast it to something else, the read object is already read. And it initializes stuff, and then it calls the runnable. So, again, in.read object is called. So the execution of this already took place. This means that if this execution is, for instance, a command on your system, even though it's not a value object, the command already took place. Let me show you. So I have an application over here. I have that gadget that I showed you earlier, and you see that gadget has that runnable. What I'm doing here, I'm serializing it to gadget.ser. Let me do that us as the first step. So let me run this. Demo gods, oh demo gods, please bear with me. Yes, this works. Should be. Okay, so now gadget.ser is here on my screen. Cool. Now I'm going to deserialize it. And you see, as a side effect, the gadget has the command env, showing my environment variables. So if I deserialize it, I expect a value object, but it's not, it's a gadget. So if I do this, and I deserialize it, let me enlarge this for you, then you see that you see all my environment variables, and then you get the Classcast exception. So the thing is, if there is a gadget available in your class path, we can use this to execute code on your machine. And then you will say that, yeah, sure, but I don't create these gadgets. Of course not. You don't. But how much of your code is the code that you actually wrote yourself if you look at the binary that you put into production? Who was here at the previous talk from Teresa and Katie? Then you know that's approximately 10 to 20%, that's the code you own, you wrote yourself. The other 80 to 90% is something you inherit by dependencies. So you don't know if your dependencies are having these gadgets in place. And everything that is technically on your class path can be loaded into memory. Fun. So we can do this. But the thing is, it's not just a single gadget, and the gadget I showed you is a single gadget, but most of the time it's a gadget chain. That means we need an entry gadget, which is something that overrides the read value or the read object value. Then we can connect that into something else, into something else, into something else. And finally, we have a gadget that can instantiate runnable, or the runtime, or the process builder. And if I chain all these things together, I have a gadget chain. The gadget I showed you before is simply a gadget chain of one. But normally, gadget chain consists of more things. And then a lot of people will probably say, like, yeah, fine, but who overwrites the read object value thingy? I wouldn't do that. Check the implementation of HashMap, please. HashMap already overrides this private final void read object thing. The reason for that is because they want to be backwards compatible, bytecode compatible, so it's possible. But technically, my HashMap function, or HashMap, is already an entry gadget. Now I just have to find in all the classes that you put in your class path together which ones I can connect to each other, and then maybe there is one class that can instantiate the runtime or the process builder, and then I have it all solved. But that is hard, right? It's hard to find, like, browse to all these classes in your system and see if there's actually a gadget chain possible. But why so serial? YSO Serial is an actual tool. And what I said now, they already did it for you. Oh, by the way, quote mark, this is for educational purposes only. Don't try this at home. It's taped, so I have to say this. Do not do this. All right. YSO Serial is a GitHub repository, and it's a tool that can create these gadget chains for you for known gadget chains in certain libraries. And this is what they have. This is partially what they have. They have much more. It can be a single library like this one, Commons Collection 3.1. If you include that library, that already contains a full serialization gadget. From the start to the end gadget, it's already there. And this tool can create the payload for it for you. But it can also be a combination of multiple libraries. One library, a few classes of one library with a few classes of another library, etc., etc. Connect that together, and we have a payload that can execute code. What I will do is, I'm going to use this one. Commons Collection 5, they created 5 different ways of using Commons Collections to create such a gadget chain. Let me get into, and I didn't prepare this, but it's always fun to do something different while you do a presentation. Let's look into YSO Serial. Cool. Now let's go into and see if we can find the payload. The payload over here basically uses, and this is the shorter form, it uses the lazy map, and it uses the invoke transformers in Apache Commons 3.1 to call different things, like you might see it over here. it uses the invoke transformer to get method to invoke something, and we basically invoke an execution. Oh, it gets the runtime, and then it executes something. So by connecting these invoke transformers to each other and create a class and a class and a class and a class, and put that into a lazy map, and I make a stream of that, and then you can put it into your system and execute code, which is normally not the way how you want it to be. So let me try this. I have an application here, and yes, this one we knew. I can change this one. I already downloaded YSO serial. Hello, terminal. Yes. So I have the binary here. It's a jar. I use commons collection 5, and the execution I want to do is touch hellopeople.file, and I put it into payload.ser. So if I execute this, payload.ser is now available on my machine. Cool. This is the code I'm going to execute. And of course, these are code snippets. All of it is available. What I'm doing here, I'm loading the lazy map, so I actually know that that thing is already loaded in memory. And most of the time, if you load a library, you actually use it. Hopefully. If you're not, you should remove it. That's another lesson. That's another talk. But hey. So, and what I'm doing now, again, I'm just loading payload.ser, and I hope it's a value object. But we already seen what happens. So if I do this, and I run this example, and we see it works. I have my Classcast exception, but under the hood, I already created hellopeople.file because I'm using this payload, and I have this library as a dependency. And you know that in many companies, if a dependency is in and it works, never touch it again because nobody wants to work on that. Let's get to the new function or the new feature that I need to do on my Scrum board. So updating these things might be useful in some cases. So, well, this is fun. But then you would say like, yeah, okay, but these are old and I updated my stuff, so I have nothing to worry about. And how hard is it? How many of these chains are there? Well, I'm gonna go to this slide, and this is a slide I stole by Ian. It's a slide from Ian Haken. He presented this at Black Hat US 2018. He works at Netflix. And what they did, they created a tool to see if in their own application, in their own web application, if there are gadget chains available. So they scanned everything, tried to match everything, and see if it was possible. This was one of the outcomes. The combination of 6 libraries and the Java runtime environment created this gadget chain. So something from ThoughtWorks, some Apache Commons stuff, some Netflix collection stuff internally, something from the Eclipse Foundation, connected with the Java main libraries that are already there, created a gadget chain. So you can imagine if you have hundreds of libraries already in your application, because we all use Spring Boot, right? Yes? No? Yeah, exactly. And we have no clue what's coming in, that it is possible to get such a gadget chain. The thing is, finding it is hard. But once somebody found it and put it in YSO serial, then it's fun. Try it at home. And then people say, yeah, sure, but we don't use Java serialization, so I am not vulnerable. Question, and I want an honest answer. Do you know where you were at December 10th, 2021? I heard some people grinning. Who of you heard of Log4j? Okay, who of you did not heard of Log4j? Thank God. If that was the case, please get out. But no, Log4j was a very intrusive problem. A logging library, etc., problem, executing code. Thing was, it was a transitive dependency for many of our customers within Sneak. We scanned it, and about 60% of our customers had it as a transitive dependency, so they didn't know. They did it because they had some package that was depending on Log4j. We saw that at that point, December 10th, when this was publicly announced, that over 17,000 packages on Maven Central were vulnerable because that was the only version out. Over 800,000 attacks were committed in the first 72 hours. Most of them were automatic because people script things. And we don't know what the actual result of that is because people don't report that. However, it was a big thing. And technically, this is a deserialization issue. So, Log4j. Interesting. So say we have an application. For those who don't know what log4j actually does, I will give you a TLDR again. So log4j, I have an application, and sometimes I know that something will get logged. For instance, an error log if I log in with the wrong password and a username. It's obvious that you would put a log line somewhere, user X failed to log in, or something like that. But if I know that the username will get logged, I can do something like this. I can do a JNDI lookup. And a lookup means not only looking at something, but actually retrieving the object. And I can buy that with the LDAP protocol. Well, if I own the LDAP server, which was the case over here, evil.com is mine. I wish it was. But if I do that, I can put back a reference to you. And that reference points to a precompiled class, which I serve to you on an HTTP server. Once that class is in your application, it automatically executes something, because that's what that class does. So say my class looks something like this. If it implements the object factory, then it definitely will call the getObject instance. And in this case, I simply say, hey, open the calculator by using the runtime.execute. So even though it's not much fun to show you, but I have a demo, and I created it this morning, so I hope it works. To show you, this works on, you see the highlighted part in my terminal over here. It's an old version of Java 8, and I will come back to that later, why this is important. Build 111, because it sounded fun. What I can do is, if I put a username in like Devox and put the wrong password in, and I sign in, then you will see at the bottom that failed login attempt username Devox. So I know the username will get logged. Well, I have my LDAP and my HTTP server running just as I showed you in the graph. So if I connect to, and this is on my local system, connect to my local system.999/evil and put in the wrong password, and I sign in, then you will see my calculator bumps up. So I can execute code on that. Well, you would say this is interesting if you want to calculate things. How about something real? Well, yes. Because at the point where we were researching this thing, and I know there will be some other folks in the room that researched this as well, and we shared knowledge on that. We first thought that it only happens with older Java versions, because in the older versions, there was this trust URL code base parameter for the JDK that was set to true by default, which means that the remote code, even I don't have it, I don't own it, I trust it, which is bad. Newer versions, newer builds, say Java 8, build 191, on newer versions of Java 7, they have this parameter set to false by default, so we're not vulnerable anymore, right? Wrong. Because Java serialization, the gift that keeps on giving. So, let me give you another thing. I have this application running, but I will close it and I will open the same application in a Docker container. And why I'm doing this, because then we are running the same application in with a newer version of Java. Well, that was fast. So Java 8, build 342, which is higher than the 191. We agree on that. The thing is, now I just change my server, and let me go to the server. I'm not just showing the evil dot. This is what I did before, fine. But now I change my server to something else. Let me show you. I'll enlarge this, and over here. So I'm not calling evil.com/evil. No, I'm calling it /comments. And now I'm going to send a command using the comments collections library that I showed you before. You recognize this code? This is the code I just stole from Yson Deserial. So I'm creating the same payload because I know this application has that same library in it. I'm again calling the get method and invoke the runtime, and I'm executing that code. And now I'm just sending it as Java serialized data. Oh, to make it a bit more fun, let's not do the calculator again, because calculating things, I've got a phone for that. Let's do this. Who knows what this is? we call this a reversed shell attack. So I'm executing code that you, as the client that I want to attack, are trying to connect back to a server on a certain port, which allows me to hook up to that and have a shell access. So let's try this. What I need to do, the only thing I need to do is I need to use netcat, and I'm listening to port 9000. So let's do that. Let's reload this one because this is not the one that now it runs in the application or in the Docker container. And instead of going to my local host, I am going from my Docker container back to my local host because that's where my LDAP runs. Wrong password because I know this will be executed. And if I sign in, ta-da, I'm in. This is a Docker container that runs here locally, but I can also run it in the cloud. So, okay. And if you look good, you already see the answer. What is the default user Docker uses for your applications? Root, exactly. So who am I? I'm root, thank God. Now I play around, look around, install my Bitcoin miner, and good luck with your AWS bill next month. You see, even if you're not using serialization, this is technically a serialization issue because it's implemented with reflection and all that kind of stuff. And Log4j is that harmful that it triggers that. So even if you're on a newer Java version and you're like, hey, I don't upgrade, please do. Thank you. So, okay, fine. But what about newer JDKs like 16 and 17? And what about records, right? Because records will solve everything. Well, let's take a look at records. I put a record in, I created a record here, and we called it toValue because it contains two values. Two strings in this case. And in this case, I specifically overwrote the constructor. Normally, I don't have to do that, but I wanted to create a side effect to show you how it works. I'm just printing out, hey, this is created by the constructor. So this is the same code I showed you before, serializing the stuff and deserializing the stuff. But I'm now printing like, hey, I'm serializing the stuff and I'm deserializing the stuff. I can demo this as well real life, but I think this is easier. If I look at the output, this would be the output. So the first output line says, okay, you're creating the toValue file, which I do in the first line. Then I'm serializing it. Sure. Then I'm deserializing it. But then I see again, create a toValue file via the constructor. So we know in this case that the difference between POJOs, normal POJOs, and records is that if you deserialize records, they use the constructor to actually create that thing again. So that already solves the validation problem I talked to you in the first place. So if you have logic in your constructor, it will get called when you use records. But will this solve everything? Well, we still have this. So that means unless you do everything with records, then you're not sure what's getting called. And still the read object file will get called. So every library and everything will get streamed in first and then get costs. So technically we still have the same problem, but records already make it a bit less horrible. Just a tiny bit. So records are not a solution, although records are already an improvement. So, but what can we do? Well, changing everything to records might not be a good thing, but what can we do? Well, for instance, if I need to implement serializable, you can implement this. So you know that if somebody or you or a fellow junior developer, because we're all senior 10 times developers, of course, tries to implement something, it will get destroyed, or you get an exception. But that is not always feasible. Say you need to implement serializable. One of the things you can do is you can use a library that inspects that input stream. Apache Commons IO does that for you, for instance. They are not using an object input stream. No, they are using a validating object input stream. As you can see, I can create an acceptance list. In this case, I only accept value objects instead of the gadget, for instance. So I will not end up in a Classcast exception. It will already get killed for you while you were reading that stream. So that side effect will not get called, and only the object that you want where it will be in your memory. Java itself also has filters. So what we can do, and you see that on the third line and fourth line, is I'm creating an object input filter here. And with that object input filter that was created with JEP 290, I can create allow lists, decline lists. I can go look into arrays and call them maximum depth and all that kind of things. And over here, I'm just saying like I only allow value object and everything else I decline. This sounds okay, but it needed an improvement, and that improvement was done in JEP 415, which was released in with Java 17. The thing is that you can create these input filters on either a global level or stream level. And it sounds fine, right? But if you create something at a global level and then create something else on a stream level, the one on the global level will get overwritten. That's not good, because maybe I'm not overriding it, but what are my libraries using? Are they overriding my thing? You don't know unless you inspect all the code. So what we could do in JEP 415 is actually set a filter factory. And in that filter factory, I'm allowed to describe how I combine two filters if I set a filter for a specific context, and I have a global filter. So let me do that for a second, just to show you that it's actually true, and I'm not just messing around. Say I am having a gadget over here, but that's not really the thing. I am having an object filter and the set filter factory, and what I say is, hey, merge this in the normal way. Cool. Then by deserializing, I create a new object filter. And just to show you, I print out the object filters to see what is the result of it. So let me execute this one. What we can see now here is that it's the merge product of two predicates, and it will get declined or accepted. So you have to figure out like what you want, but you see that it's the merged product. If I don't do that, and I run this again, you will see there's only one predicate, and it overwrote the global one. So that is not what you want, because if a library does something different and you have no clue what it does, if it uses serialization or not, and it sets a filter, that might overwrite your filter that you already committed for your whole application. So use that newer version, use Java 17, use JEP 415 to describe how you can combine these filters and actually be safe. If you want to know more about this, I wrote a whole piece on it. You can look at it. You can have there are multiple code examples, and well, you can just copy paste it like you do from Stack Overflow. Yes, that was a joke. Anyhow, who of you is like, but I'm not using serialization. I'm using JSON. Let's talk JSON. JSON deserialization by Json, or sometimes we call it parsing, marshalling, pickling, but it's the same thing. Object, stream, and from a stream back to an object. JSON is just a readable format. So one thing you can do with Json is, see here on line 2, enable default typing. Whoever did that? Thank you. Don't ever do that. Because by default, default typing is set to false. What is default typing? Say I want to deserialize a piece of JSON, and I don't know if it's a cat or a dog, but I know it's an animal. I can just say animal, and it will traverse back to either cat or dog. So I can use the inheritance tree to see to deserialize stuff, which sounds useful from a developer perspective. But if I take this to the extreme, and instead of my person class and the name is not a string but an object, it can technically be anything. So you see over here that I enable default typing, and I can enable default typing on the global scale again or on a specific field, and I do it both here just to show you. And if I deserialize this piece of JSON, oh, I wish I was 37, by the way, all will be fine. However, I can also deserialize this piece of JSON. Again, if there is a gadget available, which executes some code, I can just call it, because in the end, everything is an object. And you might say, like, I only have 15 minutes left, so I don't show you, but you believe me that the ls.l will actually get executed. So you're not safe by just using Json. No, you have to be aware that you use the right configuration. The folks that maintain Json do a great job. They set this one to false. So don't think like, hey, it's a feature, let's put it on. Please don't. And you might think like, how many of these gadgets are actually there that can be triggered by Json? This is the partial list of 2020 and 2021. These are all the gadgets located in, most of the time, third-party libraries that can be used in Json to actually execute things. Every time something is found, the Json folks put it on a block list and actively maintain that block list. So that's why you get so many of these things. Hopefully, if you're, most certainly, if you do not enable default typing, you are not directly vulnerable to it. However, again, you don't know if other libraries are enabling default typing, yes or no, and then still. Thing is, update this. Make sure that you're on later versions or newer versions of, for instance, Spring Boot, because Json is delivered to you by the Spring Boot starters. And if you're like still on Spring Boot 1.15, that might not be great. So it happens. And the maintainers are keen on this and are doing their best to update and to block this. And it's up to you to make sure that it's not in your system and you update to the newer versions. So, and what I want to say, do not enable default typing. Right? Okay, thank you. Who likes YAML? Who actually, we need to talk. 2 people like YAML. Hey, fine, not judging. A lot of people hate YAML, including Bruno Borges, who is still probably at the Microsoft booth. So I want to connect you two together. Anyway, YAML, you're like, yeah, but it's also a format where you can deserialize data and serialize data. But what can go wrong with YAML, you would say? Everything. That is the right answer. Let me see where I have my application. So I have an application. I have that application over here, and let me log in. Of course, my password is admin, because I work at a security company. But this application is not really interesting. It has a lot of users with a so-called username. But I can also import new users using either XML or YAML. Okay, fine, you would think. But what's wrong with that YAML of yours? Well, let me see where I have my examples. So the good way to include YAML for this application is this. Like a new user, it will get you read the username, the last name, of course the password in plain text, because why not? And you insert it into the database. Of course, you don't do this at home, but I hope you understood the sarcasm. The bad thing you can do is this. And we call this a billion laughs attack, which is actually something that was already available in XML, but most XML parsers already cut this one out. Let me explain to you what happens. In YAML, you're allowed to set pointers or tags. In this case, I am creating a variable lol1 with a tag lol1, which is a list of LOLs. 10 times I'm laughing my ass off. Then lol2 is a list of lol1s. 10 times the list of 10 laughs, etc., etc., etc. lolz is a list of lol9s, which is a list of lol8s. You get the point. Instead of the first name over here, I am reading the LOLs. What happens is all the traversing will take place, all the strings will get into my heap, and then technically I will have a memory overload, which is not a bad thing if you're running on a local machine. But guess what? Most of us are running on What kind of cloud? Good luck with your bill at the end of the day, or your availability. So what I can do, if I'm trying to do this over here, and let's choose the file, let's go to the code workshop. Which was it? Last two. And if I open this and submit it, it will just run and it will try to traverse all the things, get all the strings into memory, which is fine, and will give me an exception over here. But that exception is no, not this. An out of memory exception. Say you're working for Amazon, the web vendor Amazon, not web service, Amazon. And it's Black Friday, and I'm your competitor, and I know this YAML is possible in your system. I'm just doing that 20 times, you're not available, and everybody comes to me. So availability is a thing, and it's a security issue. We always think of security like, don't get your application data stolen, but availability, for instance, for a tsunami warning system is kind of interesting. So if you're not available because of these real weird issues, The thing is, I'm using an outdated version of the YAML parser that is served to me by Spring Boot again, Snake YAML. And if I would have updated from 24, 25, let me see, I have it somewhere here. I scanned my application, so I know the exact words. Here. Snake YAML 1.25, and if I would update it to 1.32, I would get rid of a bunch of vulnerabilities, including this overload. So doing this on your local machine makes sense. Updating to the newer version makes sense. Make sure that you know if there are vulnerabilities and make an educated decision if I need to change this. But again, if you're just using YAML to say, well, I'm fine by that, it depends on which version of the library you're using. Last one. Where's my slide deck? Over here. XML. We all love XML, right? I love it. I mean, with XML, we have pretty much the same issue. You think? No, not. The LOL of the billion laughs attack is not a thing in XML because most XML parsers look at the depth of how deep you go and just cut it off, just like the YAML parser does if you need to use the newer YAML parser. But say XML. Let me get back to my application again. Where was it? Here it was. Okay. So I could upload using YAML or XML. So let's go for the XML part. And instead of, is this the right one? This is the serialization records. Too many browsers open and too many things open. This is the right way of doing the XML thing, exactly the same as I did with YAML. 2 users, plain text password, because why not, and some comments. But every XML parser in Java that is served to you is vulnerable to external entities. To what? External entities. This. External entities is considered a feature in XML because you can use it to call in DTDs to validate your XML. But guess what? You're not going to only call DTDs. You can call everything that you're allowed to call, or sometimes not even allowed to call. What I'm doing here, I'm connecting on my local system to /etc/passwd, a file on my local system. And instead of printing a comment over here, I'm referring to this external entity. And external entities, by default, for every XML parser in the JDK, are currently set to, that's allowed. It's true. So if I'm doing this, and I'm choosing that XML file, which is this one, then I'm now losing data. I'm now leaking data, which is not a bad thing because it's the passwd file, but it can also be another file, like your properties file, which might or might not have a token in it to your database or to something else. So it's not what you want. And you have explicitly need to disable these external entities to make sure that you're not leaking data. So the thing is, when serializing data from XML and YAML, you can still be vulnerable to other things, not specifically code execution, but other things like you see over here. So This is the summary. First of all, if you want to serve, the first thing you need to do is prevent serialization and Java serialization as much as possible. But make sure that if you do, you don't deserialize input from unknown sources, which sounds okay, but think about it. Are you actually doing that? And are you using that in your code reviews? Or are you just bashing and bitching about curly brace should be under the second line or not, or like these kind of code reviews? But actually look at these kind of things. Do I accept things from the outside that are untrusted? Well, prevent Java custom serialization if possible, but it's not always possible. If it's not possible, use these filters as I showed you, either by using the Commons Collections or Commons.io library, or the enhanced JEP 415 with the filters and the combination of the different filters. If you're using libraries to do things for you, like the JSON library, or parsing JSON, XML, or YAML, know how these marshal lists work. Read documentation. Yes, I know, it's hard. But read what are they actually doing? And what are the values, what are the default settings? And maybe these defaults are good, maybe these defaults are insecure. But be aware of that instead of, I saw this on Stack Overflow, I pushed it in, alt tester green, push it to production. I get it, but that's not, in the end, we need to fix it anyway. So let's do it the first time. And even if you have a library, make sure that you scan, like I did on my local machine over here, and if there's an insecure library, update to the newer version, because I am not aware which classes are actually fully in my class path. Maybe you're using the module path, which you divide certain things, but probably not. And you probably have no clue which classes are there and can be harmful to a library. But if somebody found out, it's published, people that want to harm you already know. So make sure you update these insecure libraries to the newer versions that are secure. And that is, for so far, the best you can do to prevent serialization. We've got 3 minutes left. It's almost lunch, so you're early. Thank you so much for being here.